Everybody, I'm Terrence, and we're here today to talk about the future of consumer technology. And we're going to get pretty far out there. We can start talking about the most immediate things. We're going to talk about AI, and we're going to talk about interface, but we're also going to get super sci-fi out there. But first, I want my panelists to introduce themselves, tell people a bit about yourself.
Hi, I'm Annalee Newitz. I'm the editor-in-chief of IO9, which is a science and science fiction blog. And I've recently spent the past 2 years researching and publishing a book which is about the worst real-life apocalypse that has ever happened on planet Earth. And that is mass extinctions, where more than 75% of all species die out. And so that's really spurred my interest in looking at how we can prevent another one of these mass extinctions from happening, because generally they've been triggered by climate change. And so I want to talk about sort of far future technologies that are sustainable and can help us better integrate our civilizations with the environment.
And I'm Joey Ito. I'm the director of the MIT Media Lab, and we do lots of things from synthetic molecular biology to robots to opera to learning.
All right, so let's start with something a little bit more immediate. We've seen Google Glass quite a lot, and Google Now, and you're seeing a lot more application of AI into interface designs and how we interact with it. So I'm wondering, where does that go from here? How much smarter can our gadgets get? Can it get to the point where they basically take us out of the equation? We don't have to actively interact with them anymore?
So, first of all, Google Glass, the project lead is a Media Lab grad. So I'm proud of them, but I think that one of the problems, first of all, I think consumer electronics is kind of consumer is going to go away. I think we're all going to be, part of the system will be producers. So, and then electronics is also kind of one part of a bunch of different ways that interfaces work, chemical, mechanical, and otherwise, and biological. But the thing with Google Glass is it's still incremental to traditional consumer electronics, which is interacting with that part of your brain that thinks it's in charge. Kahneman would call it the S2 brain. It's the logical brain, but it's also the brain that's actually the most unaware of what's going on. And so the idea that you're taking a single little piece of interaction with that part of your brain that thinks it's in charge, the logical part of your brain, is really a very low bandwidth thing, and it's actually not interacting with a whole system of stuff that's going on that's really important for you. And so the idea of having little screens, whether they're up here or down here, I think is one piece, but the really interesting stuff is the stuff that connects with, so we're already doing, like with Fitbit and stuff like that, the health stuff, but you know, we're working on bionics at the Media Lab, where we make chemical, electrical, magnetic interfaces to the brain and the body. And then you think about machine learning, but you can also think about the fact that the more intuitive pattern recognition part of our brain isn't interacting that much when you're sort of saying commands and things like that. And so I think that the interface part should be much more biological. And I think that the devices themselves, if you think about synthetic molecular biology and things like that, will become more biological. So I think within the next few years, we will start to see more and more, and we're already working with embeddable electronics in the skin, but also in interfacing with nerves and things like that. So I think the future of consumer electronics, you will still have an attention, so you'll have stuff that you pay attention to, but the majority of stuff that goes on is going to go on unaware. You will be unaware consciously, but your system will be interacting.
Let me take that even a step further, because I think we're still kind of connected to this idea that we're going to have this Google Glass, and it's going to be just me as a person, and I'm looking at a bunch of shit, and I take some pictures of my friends, and if I ever learn to use the interface. But I think what the future will be is really not these individual level me taking pictures of my friends, but really how this technology gets integrated into our cities and our environments and civilizations. And so let me give you an example, because that sounds very vague. The city of Rio in Brazil has a problem with flooding. They get flooded all the time, there's terrible rains, and the city gets flooded, and the city needs an early warning system for floods so that they can actually evacuate days in advance instead of, say, hours in advance. And so there's now companies like Cisco and perhaps other companies that you like better than Cisco, which are creating things that are basically kind of city operating systems. And what they have are tons of surveillance devices, everything from cameras to temperature sensors to sensors that can register, how wet things are, that they can spread throughout the city, but also in the areas around the city, like the floodplains that feed into the city. And so if they're able to gather data over time about what conditions are the conditions before a flood, so how wet is the air, what kinds of, what is the surface of the ground like before you have a terrible flood, that data can be used predictively. So there'll be several floods, but they can say, actually, based on all of our sensor equipment, all of our Google Glass that's actually living out there, in trees and living out on the ground in the mud, we can say, actually, there's a high likelihood that there's going to be a flood coming soon, and we can evacuate people. And so I think to me, that's the really exciting place where technology might be going, stuff where we can actually work together as a society to surveil our environments, to monitor our environments, to be able to survive disasters. Because, of course, I'm obsessed with disaster, but we're going to be seeing more and more disasters as we move into the future, especially in, say, 200 years. Things like floods and storms are going to be a part of people's everyday lives. And so we're going to really want the planet to be wearing Google Glass, which kind of gives me a terrible image of like a planet with like a giant kind of visor. But I think that's really part of that system.
Do you think, though, with these cities, you still have this kind of idea of like the situation room or the captain in his chair in charge looking at the data? But I think the idea that someone can actually be, it's kind of like the misconception that somebody's in charge of the internet. When I was on the ICANN board, people would call us up and say, my internet's broken. It's like there is no internet hotline, right? And so I think what happens is it's like a network, and it's so there's a great Kasparov article where there was a human chess grandmasters winning, then the computer wins, and then a machine-assisted human wins. But then what wins is a bunch of amateurs with a bunch of algorithms. And that diversity in the network and the sort of resilience of cities, I think, is going to be really important. And so I think the idea that, internet people already know this. The idea that you can be in charge or know the whole of it is kind of bullshit, and biology knows this. But people in charge of cities and things still try to control. And I think, again, I'm getting back to the Google Glass control thing, but the idea of controlling nature or triumphing over nature, or triumphing over disaster, and we can make a wall strong enough to stop this thing. That's kind of this old school science fiction, and I think the new stuff, and we were talking about it backstage, but I think is how do you integrate into the system so that the bad stuff doesn't even notice you because you're just part of.
Yeah, and I think that's the next step. I think first you need to be gathering that data about what is the system, because I think that's one of the things that we still are struggling to understand is all the complex pieces of data that go into making up a storm or going into making up a drought, because drought is obviously a huge looming issue for us as a civilization as well. But I do think that going beyond something like a glass interface, what we're really looking at going toward the future is how do we rebuild the very materials of the technology that we're using? How do we look at what materials science is producing now and think about what would it mean to, for example, build a smart building that actually could repair itself so that we don't have to constantly be tearing down buildings and building new ones? What if it was built with self-healing cement that was made partly from bacteria that could extrude, when a crack forms, these bacteria could extrude a strengthening glue to hold the building together again, instead of us having to, as I said, tear it down. And so I think that that's why things like synthetic biology and materials science are far more important in some ways than traditional old school electronics, because we really are going to have to be thinking about building with either biological systems or systems that act like biology.
So here's what I'm wondering then, and to take it a little bit step back. I know talking about self-healing buildings and stuff, but this is also a consumer tech thing. So where does that material science and these self-healing properties, where does that play into like product design, as opposed to just we're going to have a building that if it cracks, it's okay. How does that affect our phones or whatever we're embedding in our brains or strapped to our arms? So how does that play into that world?
Well, I think you could maybe frame it as a design process. So in the old days, you had engineer-centric design, where we had products called Twin VQ, named by the engineer, or Henry Ford making black cars because they're easier, they drive faster. And then you had human-centric design, which is a Steve Jobs. We care about what the human interaction is going to be. And then you had participatory design, which is like World of Warcraft, where you listen to your users. And then there's co-design, which is you enable and empower your users to do the design. And there's a bunch of different threads here. So there's kind of like idiot-proof design stuff, so you can move things around, but then it spits out an actual working circuit or design. There's 3D printers outside, but we're working a lot at the Media Lab and at the Center for Bits and Atoms on assembly. So Neil's group is working on airplane fuselages, and his theory, and some people disagree, is that everything is going to be like Lego bricks. 3D printing is like the analog, and so he has this carbon fiber snap together things that you build these airplane fuselages, and if you break something, you just disassemble and reassemble. It's not about building parts. But in any case, there's a manufacturing revolution going on, and Samsung, Limor Fried and Phil Theron have bought this Samsung pick-and-place machine, which is top-of-the-line manufacturing equipment for electronics. You can just buy it and plop it in their place in the garment district. So it's kind of like Amazon AWS, but for manufacturing, because they've figured out how to do that. Now they're selling it. And so now they can manufacture. So I think there's two steps. I think what's going to happen is you're going to see super customization turning into really customized local manufacturing at scale. I mean, you see this happening in the streets in Shenzhen, but it's going to happen everywhere. And then what's going to happen is I think you're eventually going to be designing and building your own stuff and growing your own stuff, And so, and I don't think that's that far away. And I think that the companies that traditionally manufacture are already starting, and the ones that we work with at the Media Lab are thinking about, okay, do we become a platform that distributes design patterns and brands and creates communities for makers, but is fundamentally the product going to be produced by, and for food as well. And so I think that's one possible future. We don't know if it's exactly going to go there, but thinking about the evolution of design and evolution of manufacturing, I do think that you end up with a possibility of an extremely customized local experience.
And also, design is going to, design always has an aesthetic component too. And when you think about these future designs, especially what you were saying about the idea that people would be growing their own devices, that's something that really fascinates me. But as you imagine that future, you have to realize that it would be kind of an inside-out version of what we have now. Because I think now when we think of the future, we think of a sleek, clean design. We imagine our future will be designed by the ghost of Steve Jobs, and it's going to all be white, and you'll touch the wall, and it'll zing open beautifully. But if we really do start integrating biology into our designs, and if we really do start having cities that grow and act like metabolisms, you have to imagine you get home, you go into your apartment in 100 years, and instead of turning on a light switch, you have glowing green algae all over your ceiling that's lighting your house. So, which sounds disgusting because of course we spend a lot of our time, well maybe you don't, but I do, trying to get rid of algae in our kitchens and in our houses. It's the thing that you kill. But in the future, that actually may be something that we do is cultivate different kinds of algae. We might be cultivating our own energy. We might have home bioreactors where we're swapping recipes for cyanobacteria with our neighbors because we don't have consumer electronics, we actually have consumer energy, like we're growing our own energy in our homes. And so I think that will really change just our whole built environment and what we think of as technological. I talked to an architect here in New York, David Benjamin, who works a lot with synthetic biology and architecture, and he said that when he imagines a future city, a high-tech city with all kinds of awesome shit, high-speed communications, all the stuff we want to have except for flying cars, he imagines that city will look like a ruin. Everything will be covered in vines, things will look like mounds, like mountains and hills, because everything has been designed with biology. And so you don't see a big contradiction between the country and the city. The city itself is sort of integrated into its environment. And so again, it doesn't fit our current sensibilities and our current definition of technology, but that might actually be the height of technology and the height of civilization at that point. Well, not the height, but...
I don't think it's 100 years away. I mean, have you...
Really? You don't think that's...
Have you seen, like...
If it's 10 years away, I'm psyched.
I mean, because we can program biology now. So there's work that's being done at, like, UCSC and UCLA, but so in our lab, Joe Jacobson, who invented e-ink, so we saw Pebble, but he's actually now have a CMOS chip that actually sequences and prints the genes. We'll have the world's capacity of gene printing within the year in that lab. It's about 100 million base pairs. The error rate has gone from 100 base pairs, 1 error per 100 base pairs, to 1 in 10,000, and it'll probably go to about 100,000 soon. So it's kind of like in the old days, you used to make transistor radios by hand, and the yield was low and it was expensive. Well, now you can print these genes. So you've got 100 million base pairs of production. It's going to go up. You've got about 100 billion base pairs in gene bank. So right now you go into the Amazon, you hunt for stuff and you stitch it together, and DuPont can make this microbe that can turn sugar into polyester, shutting down all of the hydrocarbon-based polyester plants that year that Shell did. But now we're going to be able to drag and drop, and we just print the gene, stick it in a cell, and boot it up. And what's interesting is that so you know, like in a chip fab, you create the transistor triangle. I forgot what it's called, but they trigger and then you run it and it runs a sine wave and you check the fab. So now they've done this with biology, where they have one gene expression that creates a protein that triggers another expression that triggers another, and one of them you put a bioluminescent expression in there. So we've shown that we can get these things to pulse. And then we put another thing in there where you can get them to synchronize. You can see the petri dish within a few seconds pulsing. And then we can also use genes as memory, so you can add for memory. And this is all done, right? And then and then you have, you know, iGEM, right? There's this for those of you who don't know, you should look at IGEM, but it's a competition where all the synthetic biologists come together and show their cool stuff. And it's like, oh, I've got this new bacteria that smells like bananas, you know. So you can imagine.
That's actually the self-healing concrete that I mentioned earlier.
Is that from there? Yeah.
Project,
but I mean, it's kind of like with 3D printers. The cost is coming down so much for these gene sequencing machines. And then the science around programming is getting pretty good. There's still some breakthroughs that we need, but it's going to become a garage hobbyist level thing pretty soon.
Yeah, I think it already is.
And then it explodes. Then it explodes. Yeah. Innovation explodes. And so I think we'll have at least some version of this in less than 100 years.
Yeah, and of course you can already make a glowing green algae lamp. There was like a Hackaday video.
There's a glowing green algae rabbit.
Well, yes, there's the rabbit. Although don't use the rabbit to light your house. The rabbit doesn't like that, and it poops on the floor, and it's not a good idea. But the glowing green algae lamp is actually quite beautiful, and you can make them now. So this would just be much more integrated, I think, into the environment. So yeah, soon you'll all be living inside of giant bioengineered bubbles.
Does a future where people can, genetically engineer things and to modify DNA in their garage, does that concern you at all? I mean, there's a lot of ethical implications there.
Yeah, well, there is a task force on the security side that has a list of things. So I mean, like there are certain types of neurotoxins and stuff, and you know which expressions create it. So there's a list that you map against before you're allowed to produce genes. So it's kind of like a virus scanner, literally. There's also some innovation going on trying to create genetics that help prevent genes from mutating, because that's the other way that something can go rogue. So there are a lot of people working on it. It's an important problem. There's the obvious sort of military-like security part of it. There's a more broader ethical discussion around it, and then there's a couple of different forks, right? So there's one of stuff that goes into your body, and then there's stuff to do things like make polyester more efficiently. And I don't think there's as much controversy around making biological machines that are much more efficient and environmentally safe. or bugs that clean up oil spills and stuff like that. Although that can go bad.
Yeah, the concern about that is that what if they start
it can go bad.
mutating
The thing about bionics, though, is another one. It's not just synthetic molecular biology because. So we're trying to eliminate at the Media Lab in the next 5 years almost all human disabilities. That's kind of one of our goals, and that's brain and body. And one of the things that's interesting is for amputees. So our ankles and our knees now are pretty functional. You can walk, and you don't expend any more energy than if you had a normal leg, and they're pretty functional. And you can't tell that they're a double amputee. If you have a bad ankle, and there was a young woman who had a bad ankle, a girl, and there was another woman, I think her name is Amy Williams, who's a fashion model but a double amputee, and the young girl decided, and her parents let her amputate, because it turned out the robotic ankle was going to be much more functional than her dysfunctional real ankle. But that story kind of is okay, I think. But it's the first step in starting to figure out, okay, I'm going to start replacing my body parts with stuff that works better. And then getting to be normal is the first step. Second step is, okay, augmenting. Okay, I want to be able to carry 200 kilograms on my back and run as fast, And so we've got a prosthesis that we can slap on somebody, and in 20 minutes they're running. But then you look on the battlefield. Okay, well they chuck a new leg on and throw you back 20 minutes later. So there's a once you start to get into augmentation and rapid deployment of bionics, it goes very quickly from helping disabled people to creating Superman or Iron Man or whatever version you want, and that does have some interesting.
And I think what may end up happening is, because there are so many ethical questions around bioengineering, especially when it does start becoming stuff you do in your garage, that what we may end up doing with our technology is what's called biomimesis, which is imitating biological functions in stuff that's basically technological in order to sort of stay off that third rail of messing with life quite so much. And so one of my favorite examples is right now, you may not know this, but the Department of Energy has been investing millions of dollars into labs around the United States that are rapidly prototyping alternative energy technologies. And out where I live in San Francisco, there's a lab in the Bay Area at UC Berkeley, which is the Artificial Photosynthesis Lab, and they're working with Caltech to, within 5 years, do the basic science and a prototype of a solar fuel generator, which is modeled on how a leaf functions, how a leaf does photosynthesis. So basically the device, when it's done, will look sort of like a solar cell. It works with it's a little box that has a light tuner on it. And what they're doing is basically taking in water, taking in sunlight, and producing a liquid hydrocarbon fuel, or a liquid fuel of some kind. They're starting out with hydrogen, and then they're hoping to get to hydrocarbon fuel. And the idea is, instead of mutating leaves, or instead of getting nature to kind of create fuel for you, or instead of using fossil fuels, you imitate the way a leaf functions, and then what you produce is a carbon neutral liquid that works with our current energy infrastructure. Because one of the big problems we've had with solar is, how do you store this intermittent kind of energy? The sun shines for only half of our 24-hour period if we're lucky. But this would be producing barrels of liquid, of solar fuel that's liquid. And so the challenge from the DOE is, can you actually produce this technology in 5 years? And the lab, it may not be quite as cool as the Media Lab, but it kind of reminded me of the Media Lab when I visited, because they have, things like, they have machines for developing the kinds of materials that you need in order to do light tuning, in order to convert photons into something that can be basically a hydrocarbon. But at the same time, they have 3D printers to produce the chassis to hold all of these new materials that they're developing. And so they're doing this very sophisticated materials science, and at the same time prototyping up. Every time they have a new innovation, they're like, let's build a prototype, let's build something that you can have in your car or your house so that you can fill your gas tank. And so that's something that's very exciting, that's coming out of studying how biology works, but it's turning into something that could really be a consumer device in the next 5 or 10 years, hopefully.
So I think a lot of people, have this vision of the future too. We talked about it very briefly. We're talking about chemical and biological engineering, and is there going to be this day where we don't, devices as we know them basically cease to exist? You're going to like inject a phone into yourself. You're going to have, are we reaching a point, and talking 200 years down the road, where for all intents and purposes we have telepathy? Is that like something that's like reasonable considering the technology you're discussing?
I think so. I mean, I like the idea of injecting a phone, although it would be also nice if I could figure out a way to get rid of it too. That's always the danger, right? When we start talking about fully integrating technology into our bodies, however it's done, is that suddenly now you're getting silent updates into your body, right? So Google sends you a silent update to your phone, and that might be annoying, but at least you sort of know it's happening if the app lets you know. But if it's going into your brain and you get a silent update that isn't quite compatible with your brain operating system, and you start going buggy, that's a real concern. Or if your joint gets buggy and suddenly you can't run.
But we're learning a lot about the brain right now. I mean, there's a surge. I mean, even President Obama's doing it. I think if you start talking about 200 years from now, I think that the whole notion of communicating by voice to somebody may be old. I mean, in 200 years, we're going to be jacked into our brains. We're going to be able to create and erase memories. It may be just as easy to explain to somebody, don't tell them, just insert the memory into the person, And so once you start hacking the brain, communication changes. And I think one thing I'll say though, because I'm talking about a lot of technology that's could be really scary, and I think what's really important is shifting the design practice from trying to control nature to trying to, we were talking about embedding in, working with, empowering and enabling nature. So if it doesn't feel right, if it doesn't support natural systems, we shouldn't do it. That should be the design principle. But having said that, we're going to be moving forward, and so and then we are evolving now. Our cognitive models of our kids are different from us, and so. But I think the idea of hello is kind of like, I think that may go away, and what you'll be doing is coming up with some sort of user interface where you understand what's going on. And if like the poke, right? It's stupid, but the poke, right? Well, the poke is something, but it's not a phone call, but it's something, right? And that's going to be a precursor to a bunch of different ways to signal people. Like, I just got home is only one bit of information, so you don't actually need to call the person. So, and even today, you're probably on your cell phone talking a lot less than you ever have been, right? And so the idea that we have like a phone may disappear in a generation or two.
Yeah, maybe. I really do think it's important to think of this as a way of assimilating our technology into nature. And you might think about these kind of embedded technologies as it really will fundamentally change our communication, and we might be becoming like, say, when a dog goes into an environment and it's picking up signals that we can't hear, it hears sounds we can't hear, it smells things that tell it about the environment. And for the dog, it's like, oh, I'm smelling something. And so for humans in a century, for example, these embedded technologies may feel just as natural as smelling something. It may be that you're picking up a radio signal or you're picking up a microwave signal, but your brain processes it as, oh, I hear my friend 500 miles away doing something. Or, oh, I can smell over there that there's pollution taking place of some kind and I need to leave the area. And it won't feel like, yeah, that hello. It'll just be like, oh, I heard something, and it was just something that was 500 miles away. And it is a user interface design thing. I mean, like the Palantir guys, for instance, have figured out a way to allow people who are doing intelligence and investigation to take billions of data points and like move around in them. And I think I'm interested in making a user interface for a chess grandmaster to use a network of computers as an intelligence agency. Okay, so what's the likely next move computationally? What's the history of this person? What are all the possible moves? So that person can just focus on the emotional deception part. And I think in 24 where you have somebody in your ear and then there's this whole apparatus behind telling
I mean, that.
Or like in the show Person of Interest, where they
Yeah,
have an
exactly.
artificial intelligence saying like a crime will happen, in this area, with these intentions.
And I think the interface will be interesting to see what happens. And I think different people have different interfaces because people learn differently. But I think that kind of like you hack your WoW interface. Like some people are really into numbers, some people like 3D. I think people are going to have different hacks to connect themselves to this network of information. There's a field, actually, it's a new emerging field called human-in-the-loop computation. And it's the machine learning community realizing that humans should be in the loop because actually their intuition and some of their things are useful. And so, it's going to be less about designing consumer electronics for human beings. It's going to be designing human being interfaces so the machine systems can use humans better, I think.
So this future we're talking about, though, it's exciting, but it's also, in a way, kind of terrifying to think about. I mean, we're talking about a world where you're constantly jacked in, you're surrounded by sensors that are feeding all sorts of data about the environment back to, in the case of Rio, a government organization, and it raises a lot of questions about privacy. Do we have to give up on our traditional concepts of privacy? But even about what we consider being human to an extent when you start talking about augmenting it. Are we going to just give up on privacy and change what we think of as being a person? Is that?
Well, I have a view, but go ahead.
Well, I think we are going to change what we think of as being human. And I think that there is a lot of fear about that because there can be a lot of negative consequences, and we do have to guard against that. But in order for a species to evolve and survive, it does have to change. And I mean, I consider it a win if we are able to really survive over the next few centuries at all. And in order to do that, we are going to have to radically change our technological practices. We're going to have to radically change the way that we live in our built environments. And I think that that's much more hopeful than it is scary, because each time that humanity has taken a great leap, like, I don't know, starting agriculture. Remember before agriculture, it was kind of sucky. It wasn't quite as good as it is now.
But we were more independent and human.
But I mean, we also formed cities, we formed civilizations, we got to have Engadget expand thanks to, agriculture 10,000 years ago. And I think things like, again, industrialization, which really transformed how people viewed their bodies, how they viewed their families. It changed the way people's relationship to the land. And that was really scary. Back in 1750, people were really concerned that humans were losing their humanity to machines. And I think we're facing that same kind of shift now, and that it is terrifying, but that we have to kind of face the terror and embrace what's going to be positive about it, because it's what's going to allow us to have a sustainable civilization and survive and prevent, hopefully a mass extinction where we're one of the only species left and everybody else is kind of screwed.
And I think the privacy issue is going to go through different levels. I think it's going to get worse before it gets better. It's going to be like a flu epidemic, but I think we'll survive with an immune system. My main fear, sort of midterm, is that privacy is actually important in a democracy to be able to speak up without fear of retribution and the Federalist Papers are pseudonymous. I mean, you need to be able to speak up against power. And I think right now with the aggregation of power and the diminishing of privacy can set us up in sort of this weird local minimum where the world kind of sucks and only good for a few people. I think there are a lot of people working against it, but that's my fear of privacy. Eliminating privacy is you do lose the ability for certain types of government functions to work properly, or civic functions to work properly. But I do think that to your point, I mean, if you looked at us 100 years ago, we would look like non-humans, and
we would look like we had a hive mind. We're always,
and we're not making our own
texting.
stuff. We're not making our own food, and we just sit around and look at the computer screen, and food falls from the sky.
I'm actually curious about, since you're right in the middle of a lot of these developing technologies, do you see people developing technologies around creating privacy too? Because I think you're right that there's there's this push toward technologies that remove all of our privacy, but are people thinking about that?
So there's so Sandy Pentland in our lab, he does a lot of the big data stuff, but he's calling it the data new deal, which is basically to do big data, we need to also incorporate fundamental privacy stuff. But but privacy, just like anything else, it's like a market force. Once people realize that we need it, it will get built in. It's actually not impossible to have very good privacy enhancing technology. It just hasn't been built in. And it's going to be like spam. It's going to get horrible. People are going to realize we need it. We'll build tools. But you have to kind of build it on the edges, because the minute you create data, you can't get rid of it. So you have to build a lot of the privacy into the system of where the data is being collected, which is actually yourself and the device. And you know, I mean, and this is old stuff. I mean, we've been talking about privacy technology forever. I mean, like little things like, why should you have your name on your library card? The guard only needs to know your face and the fact that you have access. I mean, there's just so much data that's being created and collected that doesn't need to be. Even for data science, you don't need to do it. So,
yeah.
so it's just kind of like hygiene.
And I wonder about like devices, you know, like the devices that I could carry around. Like I want a scramble suit, you know, like in Philip K. Dick's novels, you know, there are people who wear suits that kind of make them blend into the background so that when they walk past a surveillance camera, they just look like whatever is behind them. I mean, is that something that you could imagine people wanting to buy? Like,
I think so. I mean, I think that the problem with so I think there's little personal privacy stuff, which is like creepy stuff. But the hard part is the
creepy personal privacy.
Yeah, but the part that I'm more concerned about is you know, the fact that you don't want to end up on a terrorist list, so I don't want to meet with this person, I'm not going to do this thing, I'm not going to say this thing, and it stifles free speech, it stifles activity because you're afraid to end up on a list. And that is a huge cost to democracy, but the people aren't really incentivized to push for that. I mean, so like you're not having your high school photos online. There's an incentive for that, a solution for that will come out. But the broader one, which is government profiling of individuals, that needs a fairly high-level conversation that's going to involve the media and involve civic action. And I think that one's actually pretty important. We're having that conversation now, which is important, but I think we need to keep pushing on that one.
So the Media Lab is not making my scramble suit. I'm
I'm
sorry, I'm just really concerned.
I think there are pieces of that, but let's talk. Yeah.
Yeah. Okay.
I think that's probably as good a place as any to leave it. Thank you very much, guys. And just remember to follow Engadget Expand on Twitter. We're doing giveaways all weekend. You'll get a direct message from us if you win.
Thanks very much.